Hi folks, this is Nat, and this is going to be your video lesson on calculating probabilities based around the word or. We're going to be spending some time looking at what happens when we want the probability of one thing or another happening. And part of doing that is that we need to be able to add and subtract fractions, so we'll be touching base with that as well. Or type probabilities are a big category of probabilities, and you've actually seen some of this before and have handled it easily without even thinking about it up to this point. We're going to make it a little more difficult though. Let me give you a quick example. If you imagine that sort of bag of marbles we've talked about before, here we've got one that has 4 pink marbles, 3 orange marbles, and 2 red marbles. So if I asked you for the probabilities of each, hopefully you'd be able to do that. The probability of pulling a pink is going to be 4 out of a total of 9 marbles, so 4/9 probability of pulling a pink. The probability of pulling an orange is going to be 3/9, or we could reduce that down to 1/3. And finally, the probability of pulling a red is going to be 2/9. And at this point, hopefully all of that feels pretty manageable. You've also seen some problems asking things like, what's the probability of pulling a red or an orange? And up to this point, you probably would have just said, well, there's 2 reds and there's 5 oranges. So the probability is going to be 5 out of 9 marbles, so 5/9 probability. And you would have been totally right. But since we're going to be making this a little bit more complicated in a minute, I want to stop for a second and think about the fact that the probability of red or orange, 5/9, is the same as the probability of red plus the probability of orange. In other words, 2/9, the probability of red, plus 3/9, the probability of orange, makes 5/9, the probability of red or orange. So when we find the probability of two things, one or the other, and put them together, what we're really doing is adding the individual probabilities of each one. And that hasn't mattered a ton, but let's make it a little more complicated, and now it's going to. Let's begin by imagining a scenario where I have a bag of marbles, same sort of idea, and I know somehow that it contains the colors pink, orange, green, and purple, but I'm not sure exactly what numbers of them are in there, at least not yet. But I do somehow know the probabilities of some of them. And the probability of pink is going to be 3/8. The probability of a green is going to be 1/6, and the probability of pulling a purple is 2/5. When I know the individual probabilities here, I actually can find a lot of other information I might want based on what we just talked about. Let's say, for example, that I wanted to find the probability of a pink marble or a green marble coming out of that bag. Well, based on what we said before, I know that the probability of a pink marble or a green marble is the probability of pink plus the probability of green, which in this case is going to be 3/8, the probability of pink, plus the probability of green, which is 1/6. From there, all I really have to do is follow my good fraction addition rules. First thing, anytime you have a fraction or pair of fractions that you need to add or subtract, is you need a common denominator. So I'm going to start by thinking about a common denominator for 8 and 6. There are lots of ways that you can find the least common denominator, but we're not going to worry about that right this second. I'm going to just say that in this case, I know that 8 and 6 both multiply up to 24. If I multiply 8 times 3 and 6 times 4, I get to 24, and I'll have to do the exact same thing to my numerator because I don't want to change it into a non-equivalent fraction. So 3 times 3 is 9/24, and 1 times 4 is 4/24. So what I'm really doing here is 9/24 plus 4/24, which is going to give me a grand total of 13/24, which is going to be the probability that I pull a green or a pink. Let's do another quick example. Let's say that this time I want the probability of purple or green. So that's going to be the probability of purple, which is 2/5, plus the probability of green, which again is 1/6, same thing as before. Same deal. First thing I'm going to do is identify a common denominator. In this case, 5 and 6 both multiply up to 30. So I'm going to be trying to get a fraction with a base denominator of 30. That would be 5 times 6 and 6 times 5. And I need to do the same thing to my numerators so that I don't end up with a non-equivalent fraction, because I want to add equivalent fractions. And here I actually notice I've already made a mistake. If you look up here, I've got, I'm multiplying my 2 by a 5, but I multiplied my 5 down here by a 6. Can't do that. I really need to multiply the same thing in the numerator or denominator, or again, it won't be an equivalent fraction. So if I multiply the denominator by 6, I need to multiply the numerator by 6 as well. So avoiding that mistake, here we go. 2 times 6 makes 12, so it's 12/30ths, and 1 times 5 makes 5, so 5/30ths. If I add those two together, I've got 17/30ths, and that is the probability of pulling either a purple or a green. And that really covers the basics of OR type probability. There is one note we should make. When you're doing this, it doesn't work if there's overlap in your probabilities. So for example, if there was a marble in the bag that was both green and purple, that would mess up this probability. You have to assume that you can only get one, not the other, not that one probability is included somehow or partially in the other probability. So it only works with distinct probabilities or probabilities that don't have any overlap or affect one another. And just because there's some really heavy fraction, addition, subtraction in this concept, it's probably worth doing just a quick fraction review. We're going to be talking exclusively about addition, subtraction here. Remember, when you're adding and subtracting fractions, the first and most important thing is you have to have a common denominator. And the other thing that I think we've stressed a little bit is that when you multiply the denominator by something, you have to do the same thing to the numerator. And if you remember those two things, you're probably mostly going to be okay. Should hopefully remember this from before, but let's do a couple quick practice problems just to do a little review. Here's a quick fraction subtraction problem. And notice I started off thinking about, well, am I adding or subtracting? So always important to think about that because a lot of people do the wrong thing just because they don't pay attention. If I think about what we just said, first thing is going to be to find a common denominator. If the denominators are not already the same, you got to make them the same. 6 and 4 are not the same, so we need a common denominator. Basically, we're thinking, what can they both multiply up to? Often we'll be multiplying up, not reducing down, although that does happen sometimes. The fastest way to do this, in my opinion, especially when you get into more complex numbers, 4 and 6 are not all that complex, is to think about what things are made of. A 6 is a 2 times a 3, and a 4 is a 2 times a 2. We can make numbers match if we think about what do they have in common and what does each need to be like the other. These both have a 2, 1, 2 already, so they don't need any more 2s, at least not that 2. The 6 has a 3 that the 4 doesn't have. So if I multiplied the 4 by that 3, it would be more like the 6. Same thing over here. The 4 has a 2 that the 6 doesn't have. So if I multiplied the 6 by the 2, it would be more like the 4. And lo and behold, that gives us the same thing. 6 times 2 and 4 times 3 are both 12. So our common denominator, our least common denominator in this case, is 12. And second rule, whatever I do to the bottom, I must do to the top. So that goes fraction by fraction. Here I multiplied the 6 by a 2, so I need to multiply the 5 by a 2 as well. I multiplied the 4 by a 3, that's different, so I multiply the 3 by a 3 as well. So 5 times 2 is 10, and 3 times 3 is 9. Now I'm ready to go. 10/12 minus 9/12 is 1/12. Remember, the bottom of the fraction in addition and subtraction, once it's a common denominator, does not change. And that's all there is to it. Here's one more, 3/14 plus 2/7. And this comes up a lot. The first thing that I'm going to notice, again, is the denominators are not the same, so I need to do some changing around. But because a 14 is actually already made up of a 7, I don't actually need to change the 14 at all. You're going to notice the 14 has the 7 inside of it already. The only thing the 7 is missing to be like the 14 is a 2. So I'm going to multiply in an extra 2, both top and bottom, and that should take care of this whole thing. I'll leave my first fraction alone as 3/14, and I'll add that to my new fraction, which is going to also be 14ths, but 4/14. And when I put these together, 3/14 and 4/14 make 7/14, which we should, at the end, reduce down if we can. In this case, that reduces to 1/2, and we're done again. I know that was a super fast fraction review, and if you need more help with it, certainly feel free to let me know. Hopefully most of it will come back to you pretty fast from your days in 3, 4, 5. Alrighty. And here are your practice problems. For each of these numbers 1 through 3, you've got finding the probability of one thing or another. And the probabilities are for each individual thing are listed up here. Notice we don't know the probability of red. There's some probability in here we are unfamiliar with, and it honestly doesn't matter. But good luck.